So we have review of factoring. Whenever you're asked to factor, you must always check for GCF first. So the very first thing you want to do whenever you're doing any type of factoring is see if you can take out a greatest common factor. So for this first one, can I take any number out of 25 and 45? What? 5. And then when you have a variable, you take out the smallest variable. So D5 and D4, I can take out a D4. And I'll show you why. I would never recommend you do this every single time, but I want to prove a point. So instead of writing it like this, I could have wrote it like this. 25 times D times D times D times D times D plus 45 times D times D times D times D. So what could I take out of all of them? 4 D's. Because D to the 4 just means you have 4 D's multiplied. D to the 5 means you have 5, right? So at maximum, you can always take out the smallest one of the both. Because you can't take 5 D's out of 4 D's. It doesn't make sense. So if I take a 5 out of 25, remember that GCFing is dividing. When you take out a GCF, you divide, right? So if I take 5 out of 25, I'm not left with 20. 25 divided by 5 is what? 5. And then D5, so 5 D's, and I take out 4 of them, I'm left with just a D. Then plus sign, I do to this one. 45 divided by 5 is 9. D4, take out 4 D's, done. That's it. Could I use round brackets instead of square brackets? Absolutely. That's pretty good. B. What can I take out of all 3 of them? A 3. True statement. And K4, K3, K to the 1. What can I take? Just 1 K, right? That's all I can take out of all 3 of them. So I put a K. Then I go 9 divided by 3 is 3. K4, take out a K, K cubed. Plus 12 divided by 3 is 4. K cubed, take out a K, K squared. And then negative 6 divided by 3 is negative 2. K, take out a K, done. That's it. What about C? What could I take out of 8 and 10? A 2. So I always have equal signs running down the side. Do you see that? Because this expression equals the next expression. Because if I distributed this 5D4 back in, I would get the original, right? They're equal to each other. That's why you write equal signs down the left-hand side. So for C, I can take out a 2 and a what? And just an X, right? Because I have to take out the smallest one. So I have 8 divided by 2 is 4. X squared, take out an X, is X. Plus 8 divided by 2 is 5. And X, take out an X, cancels. You try these. See how you do for GCFs. So let's look at D. What can I take out of D? A 4. Make sure you have equal signs running down the left-hand side. If you don't, make sure you do. I'm going to keep drilling that into your head over and over and over. You need to have equal signs because this equals the next expression, right? They're not just random expressions floating on the page. So we take out a 4, and then we're left with 3y, and minus 16 divided by 4 is 4. That's it. E, I can take out a negative 15 or I can take out a 15. And honestly, some people say, well, when do I know when I should take out a negative or a positive? In this case, it doesn't matter. But we're going to be doing rationals where we multiply and divide them. And so then we're going to want to take out what makes it so that there's something common to cancel off. Okay? So in this case, it doesn't matter which way you would go with it. I'm going to take out a negative just to prove a point. If you took a positive out, not a big deal. It'll just still be negative, then positive. So I'm going to take out a negative 15. D to the 3. Because it's the smallest one. And then I get negative 15 divided by negative 15 cancels. d to the 5, take out 3d's, I'm left with d squared, plus 45 divided by negative 15 is negative 3. So could I go plus a minus, or should I just write minus? Minus. So I'm going to go 45 divided by negative 15, I get negative 3. D cubed, take out a d cubed, done. And this isn't a difference of squares, because a difference of squares has to have a different sign, which that one does. But both the terms have to be perfect squares. So this one is, it's a d squared, but this one isn't. 3 is not a perfect square. 9, 4, 16, 25, those are perfect squares. So we can't go any further with that one. 15 is a trick question. There's nothing you can do to it. It is simplified. G, what can I take out of it? A C. Now the key thing with GCFs is if you have 3 terms, when you're done taking out a GCF, you should still have 3 terms. So I'm actually going to change this to a plus C to prove a point. I know it was a minus C, but I'm going to put it to a plus C to prove a point. So if I have 3 terms when I take out a GCF, I should still have 3 terms left over in the brackets, correct? So I go C cubed, take out a C, I'm left with C squared, plus C squared, take out a C, I'm left with C. Then people will say, plus C, take out a C, I'm left with nothing. However, I had 3 terms, I now have 2. What's C divided by C? It's a plus 1. With the minus sign, everyone will write a minus 1, but when it's a plus 1, like C divided by C, people won't put anything. Remember that you should be able to distribute back and get back what you had, right? So if I put the C back in, I get C cubed, C squared, C, correct? But if I didn't put that 1, what would I actually get? I would get C squared, or C cubed plus C. I wouldn't get the C back, right? So you should be able to check every time you take a GCF, you should check if you're right by putting it back in and seeing if you got what you had before. So that's it for that one. For H, I can take out a 6. When I take a 6n squared divided by 6, I get n squared. Minus 30 divided by 6 is 5n. Plus 42 divided by 6 is 7. Not as good as that gets. You can't factor. What can I take out of I? In this case, you could take out nothing, or you could take out a negative 1. So I'm just going to take out a negative 1 to prove that if you want all the signs to change, you can just take out a negative 1, and it changes every single sign. That's all it does. So here, if I take a negative 1 out, I'm left with 7m squared plus 10m minus 17. What can I do with J? What can I take out? Out of 18, 63, and 9. Yeah. 9. And? P. And a P. So 18 divided by 9 is 2. P cubed, take out a P is P squared. Minus 63 divided by 9 is a 7. P squared, take out a P is a P. And then what's negative 9P divided by 9P? Negative 1. And remember, we can check it back, correct? If I take the 9P times by 2P squared, I get 18P cubed. 9P times negative 7P, negative 63P squared. 9P times negative 1, negative 9P. So you should get it back if you distribute. Okay. Can I take anything out of K? When I take a 2 out, I'm left with 9x squared minus 25y squared. This is leading you to the next page. 9x squared and 25y squared are perfect squares. Because if I take the square root of 9x squared, I get 3x. And if I take the square root of 25y squared, I get 5y. So they're perfect squares, right? They're also a difference of perfect squares because there's a subtraction sign in there. I just touched the thing, made the thing jolt. So we can actually keep going with this because this is a difference of squares. I'm going to show it to you off to the side here. So if I have 9x squared minus 25y squared, when I say something's a difference of squares, it has to follow two things. This has to be a different sign, which is a subtraction sign. Cool, got that. And then the two things on both sides have to be squares, perfect squares. So if I take the square root of 9x squared, what do I get? 3, what? 3x. And then the square root of 25y squared? 5y. Now all you do once you figure those out is you write them out as two factors. So the 2 just sits in front because that's still there. Then this splits into two factors. What's at the front goes at the front. So 3x is at the front, correct? So it goes at the front of each bracket. 5y is at the back, so it goes at the back of each bracket. Does anyone remember what we do with signs? Yeah. So you need a negative and a positive to get a negative. Also, the negative and positive makes the middle terms go away. So one of them just needs to be negative and one of them needs to be positive, because when I FOIL it, remember I have to be able to work backwards, correct? I get 3x times 3x is 9x squared. And then when I do the O and the I, the outside and the inside is 15xy, the inside is negative 15xy. They cancel. So that's why they have to be opposite signs. Then that's it. And L, I can take out a 25, Z5. $100 divided by 25 is 4. Z9 divided by Z5 is Z4. Plus 50 divided by 25 is 2. Z6 becomes Z5 is Z. Minus 75 divided by 25 is 3. And then the Z5s cancel. And you could always distribute them back and see if you get what you had, right? Then we're going to flip over. So these are difference of squares. Now I told you in order to have difference of squares, you have to keep in mind two things. So whenever you have like two terms, always look for a difference of squares when there's two terms. If there's three, it can't be a difference of squares. Difference of squares is probably the nicest labeled thing I've ever seen in my entire life because it literally describes what it is. It's a difference of two squares, two perfect squares. Difference means it has to have a subtraction sign, right? Two perfect squares. So if I look here, is this one a difference of two squares? Well, we have the difference sign. That's good. How do we check if they're two squares? Well, I square root them. And I put an arrow up to help myself out. So the square root of b squared is b. The square root of 64 is 8. Did I get any decimals? Then they're perfect squares. Then I can do a difference of squares. It's as easy as that. Whatever's at the front goes in the front of each bracket. Get two factors out of it. B goes at the front of each bracket. 8 goes at the back of each bracket. Positive, negative. Could I go negative, positive? Does it matter? No. Is B a difference of squares? It has to follow two things to be a difference of squares. It has to have a minus sign in between. Does it have a difference sign? Yep. And are they squares? Yes. Square root of a squared is a. Square root of 144 is 12. So I get a plus 12, a minus 12. I want you guys to try these. C to H. For C, we have 9a squared minus 121. So we can take out, this would be a 3a. This would be 111. So then we would get 3a plus 11, 3a minus 11. You can grab your phone right now. And then this one, we take the square root of x squared as x. The square root of 81 is 9. And so we get x plus 9, x minus 9. This one, the square root of 324. I don't remember what that is, 18? Square root of 289, is that 17? So we get 18a plus 17, 18a minus 17. Could I flip-flop these? Could I go 18a minus 17 first? Yeah, it's the same as 2 times 3 and 3 times 2, right? Same thing. Okay, and then 81 minus m squared. So we can take the square root of 81 and we get 9. Square root of m squared, we get m. So we get 9 plus m, 9 minus m. This one, square root of 25x squared is 5x. Square root of 1 is 1. I'm going to tell you these are the ones that people don't spot. You spotted it because it's on a difference of squares assignment page, so that should have been a giveaway. But whenever one of them is the number 1, people don't spot it as a different squares. They'll spot 25, they'll spot 49, they'll spot 9 and 4. But the 1, people don't, it doesn't scream perfect square to most people. So honestly, if people aren't reducing their rationals enough, it's often because they didn't spot that this was a difference of squares. Because when there's a 1, it's not as easily to spot. So we get 5x plus 1, 5x minus 1. The last one I saw people do, some people spotted it, some people didn't. So I'll do it the way that most people did it. So square root of 4x squared is 2x. Square root of 36 is 6. So people have this, 2x plus 6, 2x minus 6. If you go this route, not a problem, but you have to spot that you can still take a 2 out of both of them. So you would get 2x plus 3, 2x minus 3. And then the 2 and the 2 join at the front, so 2 times 2 is 4. X plus 3, x minus 3. But what I just said on the previous page is that you should always check for GCF first. Right? Did we check for GCF first, or did we go straight to decomp, or straight to difference of squares? We went straight to difference of squares, correct? Instead, what should I have done? I should have said, oh, 4x squared minus 36, I can take a 4 out. Correct? So instead of doing it this way, I could say, oh, I can take a 4 out. Well, 4x squared take out of 4 is x squared, minus 36 take out of 4 is 9. Well, now I have 4x plus 3, x minus 3. It's the same answer. It's just easier to spot it. It's easier to do if you take your GCF up first. So look for GCFs first. Okay? All right. So for the last little bit, I'm getting you to work on a little bit out of your workbook. Actually, the puzzles and games part. Yeah, it's not nearly as fun as it sounds. It's not like puzzles and games. It's like joking. It's not a game, it's like practice questions. I'm just going to post it online because I don't like this one.
Okay,
Yep.